All right, picking up where we left off, let's graph another quadratic function that's in standard form, but it's not printed on this handout. I have an extra example that we'll just do on our own paper. So you can either grab another sheet of paper or maybe turn the packet over. There's probably a blank page there. Okay, I'm going to call this extra example 4A. At first glance, this function might not look like it's in standard form, but it is. We just have to rearrange it. So let's say you're presented with a problem like this and you're asked to graph the quadratic function in this form. I might suggest go ahead, let's rearrange it, meaning I'm going to take the negative of the binomial and put it up front, and then I'll have the -4 behind it. So I just rearranged it. Now it's in this better, more clear form. All right, so the first thing we did is that we identified that it was in standard form. I just write it down again. You don't have to write the standard form down again, but I think every time we write it, we kind of memorize it. And don't forget the square there and the plus k. All right, let's look at our example right here. Let's look at A. A is actually going to be -1 now. So when A is -1, that's less than, not greater than, less than 0, which means to us that the parabola is going to open downward. Opens down. Okay, I think the first thing we did is we identified the vertex. I'll just let uppercase V represent the vertex. So looking in this equation right here, we see the vertex is +3, -4. Remember, it's the opposite of what's in the parentheses, and then literally that number right there. All right. We can find the axis of symmetry. It's always x equals the x coordinate or the h value here, so x equals 3. Let's go ahead and begin to graph that. So the vertex is found at over 3, down 4 from the origin, so I'll just put a little tick mark here, 3, and then maybe down 4. So right here is the vertex. Remember, the graph opens downward. I'm going to go ahead and dash in the vertical line of x equals 3, the axis of symmetry. Notice right away from this, we're not going to have any real zeros because this parabola will never intersect the x-axis. Now it's probably going to have a y-intercept, but maybe it's going to occur somewhere down here if I were to extend my y-axis. All right, some of the things we were asked for was the domain, so I'll let uppercase D be the domain. That's always all real numbers on a polynomial. Okay, now the range. Well, the range is going to come from -infinity, and it's only going to go as high as, the graph's only going to go as high as y equals -4. So we have to start at -infinity, and then we're going to go to -4, and we'll include that. We have an absolute maximum, and that ordered pair is 3, -4. But again, if they ask, remember the maximum occurs, or is, the maximum is y equals -4, and it occurs at x equals 3. So we want to find the x-intercepts and the y-intercepts. Well, we know we're not going to have any x-intercepts, but we probably will have a y-intercept, but we want to go ahead and do the work. You might be asked about the increasing and decreasing intervals too. So we'll do that in a minute. Let's do x-intercepts and y-intercepts. I know my answer here for x-intercept is going to be none, but my work should support that I get imaginary solutions. So I'm going to do increasing and decreasing over here as well. As a matter of fact, we can go ahead and get the increasing and decreasing. So the graph is increasing here and decreasing here. So this downward opening parabola increases from -infinity to the x coordinate of 3, and the graph starts decreasing from x equals 3, and it continues decreasing way over here to +infinity. All right, let's find the X-intercepts. That means that's where y is 0. So the original equation, we're going to let f of x be 0. Actually, in my a different arranged form here. Oh, that's a negative. Okay, and again, to find the x-intercepts, I'm just going to add the 4 to both sides. Okay, now before I can bring in the square root, I need to divide both sides by this negative number, this -1 here. So that'll make that positive. So this becomes -4 equals the parentheses or the quantity x minus 3 squared. And I will trade sides. Let's bring in the square root. And we can see right here that this is going to be an imaginary solution. So if we didn't want to solve these and get the imaginary solutions or imaginary roots or, well, zeros, I guess, or just imaginary solutions, then I would just stop here. I would just say circle with a line through it means no solution. That means no x-intercepts. And that's because of that square root over that negative number. All right, now the visual shows that we will have a y-intercept. It'll be somewhere probably right around here. So remember, y-intercept is when x is 0. So go back to the original equation, and everywhere I see an x, replace it with 0. So this is where it gets a little tricky. So just be careful about your order of operations. We don't distribute that negative inside. We have to do the power first. So that negative comes down. This will be -3 squared, which makes that 9, and then -4. So this becomes -13. So we have no x-intercepts, and we have a y-intercept at x is 0 and y is -13. And that makes sense, because if I were to extend this y-axis, then eventually I'm going to cut through the y-axis at -13. I just found this one to be kind of an interesting problem, and I wanted to kind of go through it with you, just in case you didn't realize that you could rearrange up here in just a situation where you had no real zeros, and that's because we have this square root of a negative number. Okay, well, let's return to graphing some quadratic functions that are in general form. So I think we'll go back to problem 2. So we've got 3 of those. We've got, I guess it's right here, 2, 3, and example 5. So if we need to revisit that first page that tells us the strategy for graphing in general form, then we can go there. Okay. All right, so this says obtain the following information and graph the function below. So this is a plus right here. Okay, so notice that we are in general form. So I typically rewrite that general form. It's with the a, b, and c, so ax squared plus bx plus c. We want to identify what a's value is, so at least we have an idea of how this parabola is going to open. Well, in our problem, a is actually -1, which is a negative number, less than 0, so that tells us the graph opens down. I might also, because I'm going to need it probably, I want to identify what a, b, and c are. So a is -1, b is 2, and c is 3, because that is a plus right there. All right, for me to find the vertex, I can't identify it from h and k because there is no h and k in here. So I'm going to come down here and do some work. I'm going to find the vertex. First thing we do is we use that first formula. X equals opposite b over 2a. So I come back up here, I take the opposite of b, -2, and I divide by 2 times -1. Well, that's -2 as well. So the x-coordinate of my vertex is 1. Which means actually I can come over here and put my axis of symmetry to be x equals 1. Okay, so now let's find the y-coordinate of your vertex, or called the k sometimes. So we take this x value and we go back to the original problem and we plug in 1. So f of 1 equals, plug 1 in for all the x's. And just be careful here because, again, you do the square, which is just 1, and then you take the opposite and get -1. So you can do this all on your calculator. I believe the answer is 4. So in function notation, we see 1, 4. Okay, so that means that that is our vertex. So I'm going to come over here and get started on graphing it. So here's x equals 1 and x equals 4. The graph opens downward. I'm going to lightly sketch that in because I don't know how wide the graph is. I'm going to go ahead and dash in the vertical line of x equals 1, the line of symmetry. But at least I have an idea of what's going on here. The domain is all real numbers. I can go ahead and get the range. The range is going to be from -infinity up to 4. Include the 4. We have an absolute maximum occurring at 1, 4. And again, that's when y is 4 and x is 1. We will have 2 x-intercepts. We will find them. We will have a y-intercept. Let's go ahead and answer the increasing, decreasing intervals. Get that out of the way. Increasing. I hate to highlight it because I'm going to switch it, so I won't just yet. Decreasing, where the graph's falling on the intervals of x. So increasing from -infinity. And the graph stops increasing at x equals 1 and then starts to decrease from x equals 1 to positive infinity. All right, so let's come down here and find the x and y intercepts. So going back to the original equation, y is 0. Okay, to solve a quadratic equation, we can use factoring if it works, if the factor sum chart works out. You can try the square root property, but that won't work here. And then every single quadratic equation can be solved by the quadratic formula. So if you want to just go ahead and jump right into the quadratic formula and find the solutions, the x-intercept's fine. You know, otherwise, if you want to try factoring, that's fine too. I'm going to try factoring first for me before I go to the quadratic formula, but I don't want to factor when this coefficient on x squared is 1. So actually what I'm going to do is I'm going to come into this equation and I'm going to multiply every single term, everything in this equation by -1. That would result in changing this sign to a positive x squared and changing the signs of all the other numbers. Well, if I kind of think about multiplying this entire equation by -1, -1 times 0 is still 0, but a negative times a negative is a positive. Negative times positive is negative, and then also a negative here. So these two are equivalent. I know it looks weird and funny, but they are exactly the same thing. Let me trade sides. Don't forget your equals 0. I'm going to quickly try a factor sum chart. I would prefer factoring before I jump into quadratic formula, but some people like to just jump into quadratic formula and avoid factoring. So I need factors of a times c, or -3, that sum to -2. The only factors of 3 are 1 and 3. The larger number must be made negative, and I just checked that the sum of these would be -2. This is an easy factor because a is 1. I don't have to do grouping. If I did have to do grouping, I might go straight to the quadratic formula. If a was greater than 1, I probably would go to the quadratic formula. So this is x, and this is x, and this is +1, and this is -3 from our factors. All right, so this factor produces x equals -1, and then this factor, x minus 3, produces the 0, or the root x equals 3. So now I'm going to come up to my graph, and at -1 and +3, I'm going to put in those two x-intercepts, record them up here. Okay, now I'm going to get the y-intercept, and then I will finish the graph. All right, so the y-intercept is pretty easy. So f of 0. So if you come up here and see in the original problem that if this x is 0 and that x is 0, you're actually just left with 3. So 0, 3 is your y-intercept. So 0, 3 is right here. So I'll use these points to help me kind of finish this graph. And try and make it as symmetric as you can around the axis of symmetry. All right, let's try 3. It says use the vertex and intercepts to sketch the graph, determine the requested information. Okay. I'm going to put general form above. So ax squared plus bx plus c. I will identify that a is -2. Again, that's a negative number, less than 0. So that means the graph of the parabola opens down again. I'm going to go ahead and identify that the a, b, and c values. So a is -2, b is -5, and c is 3. So let's find the vertex. In general form, we use that formula, -b over 2a. So I'll put that here. So go find b. B is -5. So we have to make it its opposite. So that's +5 over 2 times -2, which is -4. It might be helpful to change that to a decimal since I'm going to have to be sketching it over here. And that's actually -1.25. All right, let's go to the original equation given and let's evaluate. Let's plug in -1.25. So -2 times -1.25 squared minus 5 times -1.25 plus 3. Of course, we want to do all this work on the calculator. And I ended up with 49/8, 49/8, but I need that to be a decimal because I don't want to plot a fraction. So I ended up with 6.125. Not very friendly. So the vertex has x coordinate -1.25 and +6.125. So I know the axis of symmetry is x equals -1.25. So just as best you can, this is -1 and then a quarter more and then up 6, but a little bit slightly above that. And the graph of the parabola opens downward again. I don't know where those X-intercepts are or the Y-intercept is, but kind of a sketch like that. And then we'll dash in the axis of symmetry. We'll label it. Okay, we can give domain and range. So domain, the range comes from -infinity up to the height of 6.125, and we can include it. We have an absolute maximum at that vertex, which means the maximum is 6.125 and it occurs at x equals -1.25. Right, the increasing interval is right here. So we go from -infinity up to the x coordinate. And the graph then decreases from that x coordinate of the vertex to infinity. All right, we're left to find X and Y intercepts. So X-intercept means f of x is 0. Okay, again, x squared's coefficient is negative. If I am going to try factoring, then what I would do is I'd multiply everything by -1 to get that negative to be positive, which means this would be plus 5x and minus 3. I would try factoring then, or at this point, I don't have to multiply by -1. I can go straight to the quadratic formula. So it's just a personal preference. If I did do factoring, I'd have to do factor by grouping, since this is not a 1, this is a 2. I think in that case, I think I'm just going to go straight to quadratic formula. So if I can remember what it is, it's opposite b, but I already have b here, so that's 5, plus or minus b, which is negative 5 squared, minus 4 times a, which is negative 2, times c, which is 3. Let's go ahead and extend that fraction bar and that radical. And then 2 times a, and since a is negative 2, that's going to be negative 4. Put the negative 4 down here. I know that's going to be negative 4. This is 5 plus or minus. I'm going to go to the calculator and find this, and that's actually going to be 49. I can continue simplifying because square root of 49 is 7. So I've got 5 plus or minus 7 all over negative 4. Which means I'm going to come over here and give myself some more room. I have two solutions. So the first one is the smaller one, which is 5 minus 7 over negative 4. I'll work out here. This is negative 2 over 4, negative 4, which the negatives divide out, and we get 1/2. So it looks like if that's 1, then 1/2 is right here. And the other 0 is going to be 5 plus 7. 5 plus 7 over negative 4. So that one ends up actually being the smaller one because of the negative in the bottom. So 12 over negative 4, and that's negative 3. So that's right here. All right, so it looks like my graph's off a little bit, but it's kind of hard to sketch when you have those kind of wonky numbers there. Okay, so the graph's going to come down like that. And I think I'm going to hold off over here, drawing the graph downward until I get the Y-intercept. And I have this little bitty room right here, which is all I need to find the Y-intercept. So Y-intercept, x is 0, f of 0. And if you go back to the original equation, if that's x is 0 and that x is 0, you're left with 3. So 0, 3 is going to be my Y-intercept. So right about where I thought it was. I think the vertex is about right there. Something like that. Kind of a sad looking graph. All right, and then let me record the x-intercepts of negative 3 comma 0 and positive 1/2 0. I believe we have one more. It's number 5 here. This is kind of an interesting one as well. All right, so let's graph number 5. It's in general form. Identify A is positive 1. That's greater than 0. So that means this parabola is going to open up. Got it. All right, vertex. Oh, let me come up here and indicate A, B, and C. So A is 1, B is negative 2, and C is 1. So the vertex formula is x equals opposite B, which makes that positive 2 over 2A, and A is 1, so that's just over 2. So 2 divided by 2 is just 1. And let's find the Y. So go back to the original equation and plug in 1 everywhere you see an X. And do all that work on the calculator, and I believe you get 0. All right, so we've got the vertex 1, 0. So what's interesting is that that vertex falls right on, lands right on the x-axis, and the graph opens up, so kind of lightly sketch it in. Okay, does this graph have any x-intercepts? Yes, it does. It has just one. It touches instead of crosses, but that's still one x-intercept. All right, I think we can fill in the rest of the information. Let's go to finding the x-intercept. So I'll leave you to fill that in, and then you can check the key. So the x-intercept is when y is 0. Okay, instead of going to the quadratic formula, I would try and factor this first. If I can't get a factor sum chart that allows me to factor it, then I would be forced to go to the quadratic formula. factors of 1 times 1 that sum to -2. Well, the only factors of 1 are 1 and 1. And I can make them both negative. So the sum is -2. So don't forget the 0 equals. I could have traded sides, but I'm fine here. I have an x here and an x here, and notice I have a -1 and a -1. This is a double zero or a double root. Notice that this binomial occurs twice. That's what we call multiplicity 2. And what happens is the graph of the function is going to actually turn around at that x-intercept. It doesn't cut through the x-axis. We'll see more about that in a later lesson. All right, set each factor equal to 0. Add the 1 to the other side, so x equals 1 is your x-intercept. And that would be the same thing here. So for my x-intercept, I'm only going to report that I have 1. It just occurs, what we say, twice. And then I think that was what was interesting about this problem, so I don't know that we need to finish anymore. You can fill it in and then check the key. Okay. All right, one last problem on this last sheet right here is actually an application problem. We won't have time to get to problems like 7 and 8, so don't expect anything like that on the homework or the test. Okay, but something like 6, yes. So give you a moment to kind of read through the stem of the problem and what's going on and maybe some of the questions, and then come back and we can finish it together. All right, so in the very beginning of this whole section, there was mention about quadratic functions model projectiles. Well, this is the case of, I think it's a ball just being thrown upward and outward from a height of 6 feet. So let's do this. Let's kind of build a graph that models this situation. So if I'm standing on this platform and I'm at 6 feet, and from this point right here, 6 feet, I throw a ball upward and outward. Okay, maybe something like this would model what happens with the ball. So a ball is thrown upward and outward from a height of 6 feet. Got it. The height of the ball, which is along the vertical, f of x, which is measured in feet, so we'll label our axes, can be modeled by this quadratic equation. It's not very friendly because of those decimals, but it's still a quadratic equation, where x is the ball's horizontal distance in feet from where it was thrown. So this is x, and this is also in feet. Got it. What is the maximum height of the ball? So we want to find out what this y value is right here. So it's the vertex. What is the maximum height of the ball, and how far from where it was thrown horizontally does this occur? Meaning I really want to know the coordinates of that point. I want to know the x that gives that y. Well, let's think about what we're finding. We're finding an absolute maximum. We want to know the vertex, and then we have our answer. Can we find the vertex of a quadratic equation that's in general form? Yep, we can. So the maximum height is going to be found by, in general form, opposite b over 2a. So in the context of this problem, b is 2.4. Let's make it negative. And then 2 times -0.8. So if you go to your calculator and you find that value, you're going to get 1.5. So that's going to be the distance from this origin over here to right underneath the maximum height of that ball. So that's 1.5 feet. How do we get the actual y value? Well, I'm going to kind of put an arrow here. Okay, well, we're going to find the height by plugging 1.5 back into the original equation. So a lot of calculator work right here. And when we finish that, we're going to get a height of 7.8. Yeah, 7.8 feet. So the ordered pair of this absolute maximum is 1.5 and 7.8. So I was standing on a 6-foot platform, so it looks like I only threw it like 2 feet above me before it starts to descend. So the maximum height is 7.8 feet. And this occurs at 1.5 feet from where it was thrown. So B, how far does the ball travel horizontally before hitting the ground? Well, if this represents the ground right here, then we're really looking for an X-intercept. So what is this X-intercept? We have to think, well, how did we find X-intercepts? Okay, well, that's going to be where Y is 0. And then we want to round to the nearest tenth. So, all right, so let's go ahead and I'm trying to find some room, maybe down here. Let's find the X-intercept. That means Y is 0. So back to the equation, 0 equals I am not going to try and factor that with decimals. So I'm going to go straight to the quadratic formula. Opposite B, B squared minus 4, don't forget A is negative 0.8 times C, which is 6. And that's all over 2 times negative 0.8. So I would just suggest on a calculator of our kind, I would suggest finding what this value is and then going back and doing all of this maybe on the calculator. Negative 2.4 minus the square root of whatever number that is, and then taking that answer and dividing it by negative 1.6. So just kind of bypassing that, I'll show you the two solutions we get. Okay, these are the two solutions we get. So can we have two answers? Do those both make sense? Okay, which one of these answers in the context of our problem is applicable? Well, I can't have a negative distance, then I'd be throwing it back this way. So it must be that the only answer that makes sense in my problem is 4.6. We call this negative answer, which is definitely something we got from using the quadratic formula. We call this extraneous. Think of extra, extraneous. In the context of our problem, because we put context to this equation, that number wouldn't make sense. So how far does the ball travel horizontally before hitting the ground? Well, when Y is 0, it has traveled 4.6 feet. All right, and again, one more time, we are not going to do these problems. You won't see them on your homework, your tests. Just this right here is something that we're kind of expected to be able to do in context with a quadratic function.